This is Mike Boos presenting the direct instruction model in Earth Science class. Good morning, class. We've been learning about unstable isotopes of elements and how they can be used to date rocks. Today you'll be using radiometric dating to determine the age of the Earth, Moon, and a meteorite. I will give you a worksheet with 3 problems on it. We will work the first problem together, and then you will each work number 2 and number 3 independently. We will then go over your results together as a class, and you can make any corrections necessary. You will turn in your worksheets in the turn-in basket on my desk as you leave the class today. You may use any electronic calculator device you choose, and please let me know right away if you have any questions or there's something you don't understand so I can help you with it. And it will be helpful to pay close attention as there will be one or more of these problems on the upcoming test. Hint, hint. Please pass these worksheets in accordance with our passing procedure. Okay, you will remember that uranium-238 is an unstable isotope due to its extra neutrons, and it slowly breaks down into lead. The rate of its breakdown is known, and we use the symbol lambda to indicate the breakdown rate. And in case for uranium-238, we're going to use 10. The age of a rock or meteorite is represented by the equation T, which represents the age of the rock in years, is equal to the concentration or the amount of uranium-238 left in the rock times the amount of lead that's left in the rock, in grams of course, for both of these, times our constant, which in case for uranium is 10. So let's read the first problem. A rock from Earth is analyzed, and the total amount of U-238 in the rock is determined to be 20 grams. And the total amount of lead left in the rock is determined to be 10 grams. So we substitute for T equals uranium. Uranium is 20 grams, multiplied by total amount of lead left, which is going to be our 10 grams, times the value for lambda, which for uranium is what? 10 grams. Okay, and that gives us a history, an age of the Earth, of this rock, Earth rock, 2,000 years. Okay, now you can work problems number 2 and 3 by yourselves. Raise your hand if you have any questions or trouble. All right, I am now doing formative assessment by going around the desks, meeting with the children, checking the students' papers, seeing how they're doing, seeing if they're learning those processes or understanding. All right. Okay. So now that everyone is finished, let's go over problems number 2 and 3 together to see how well you learned this dating technique. Please correct your own papers. So let's read the second problem. A rock from the moon is analyzed, and the total amount of U-238 in the rock is determined to be 30 grams, and the total amount of lead left in the rock is determined to be 20 grams. So what is the age of the rock, moon rock? Using our formula, we know that the T equals the amount of uranium left in the rock, which is, in this case is 30 grams, times the amount of lead left in the rock, which is 20 grams, times our constant for uranium is 10. So we now have the age of the moon rock to be 6,000 years. Did anyone get a different answer? No? Good. You did very well. We now have found the age of the moon rock using radiometric dating. So let's read the third problem. Okay. A meteorite is analyzed, and the total amount of U-238 in the rock is determined to be 40 grams. The total amount of lead left in the rock is determined to be 30 grams. What is the age of the meteorite? Using our formula, we substitute for uranium 40 grams times our lead, which is 30 grams, times our lambda constant, which in this case is 10. So therefore, we multiply that together and we get the age of the meteorite as 12,000 years. Anybody get a different answer? No? Good. You did very well. We have now found the age of an Earth rock, a moon rock, and a meteorite using radiometric dating. I'm sure you'll all ace the test. The bell is about to ring, so please put your name on your worksheets and pass them in the, or place them in the turn-in bin on my desk as you leave. Good work today.